Hello everyone, welcome back to my channel. Today let's go over a medium question that I just solved on my own after a lot of trial and error for a long time. I don't know how I managed to solve it on my own today, but I did. So I'll go ahead and show you my own way of doing it. Again, I was surprised that I solved this by myself on my own, whatever you want to call it, but let's go over it. So basically you are given two strings S and T. They're the same length and they're anagrams, meaning that the frequencies of each character are the same. So C appears once in both, B appears once in both, A appears once in both, A appears twice in both. And what you want to do is try to split S into two substrings or three substrings such that basically you can create T by rearranging them. And it's easier to show you with a picture. So if we want to split S into K equal size substrings, let's call this size is length of S divided by K. All right, so if we want to split a length 6 substring into two substrings, then we have two substrings of length 3, right? So for I in range length S minus size plus 1, let's call this substring is S of I plus size. Let's print this out just so you can see. Okay, so basically, let's also do this. The step size is going to be size because we don't want to repeat substrings. We don't just want to go 1 and 2. We want to actually say 2, skip forward by 2 to get this, right? So what this means now is that if you can basically reorder these in any way to create B, then return true, otherwise return false. You can see here that there is no AAB in T, so we can return false, right? Here you can rearrange this BB, AA, CC, first, second, third, so it's true. This first, second into T, so check, that's true. Okay, so let's call this S parts, and we are going to obviously append the chopped up size of S inside of this. Let's create another called T parts, and we're going to basically do the same thing, because if you sort these letters, you'll notice that length of T minus size plus 1 and size, T of I plus size, and then T parts dot append substring. Let's print S parts and T parts. So what you'll notice that now if you sort them, and again, I just played around with this a little bit by myself. Again, I'm surprised I figured this out by myself and was able to solve it on my own, but basically if you print things and you'll see that they line up or they don't line up, because this is not equal to this because they're already sorted in ascending order, right? In lexicographical order. So A comes before B, A comes before B. So that makes it easy to just parallelly compare each index and say if there's already a mismatch, then return false, because there's no way, there's no BCC inside of T, no matter how you slice it, right? So what that does is allow us to, since we want to say S should match T, then if S doesn't match whatever the current 0 index at T, then we return false. So for I, V in enumerate S, or S parts, right? We're using this list that we just created and we just sorted in lexicographical order. So if the current index value is not equal to T parts of I, the same index value, then we can return false right away, right? There is already a mismatch. Otherwise, if we reach the end and we never return false, then we just return true, right? So let's go ahead and run this. And there you go, passes all test cases. Again, this is not the most efficient time or space complexity, but it is my own solution that I came up with by myself. Was kind of surprised about it, but yeah, as I already reiterated like 5 times. So anyways, that's it for this video. Hopefully you found it helpful, and stay tuned for more. Thank you for watching.